All right, let's get started. Welcome, everyone. My name is Mark Albert. I'm the Director of Science and Stewardship Partnerships for the National Parks of Boston. I want to start out tonight by acknowledging that we're on the ancestral territory of the Massachusetts tribal nation, who've lived on and cared for this land and water for thousands of years, and who continue to live here and care for this place today. I invite all of us to take a moment to reflect on what it means that Indigenous people have been here across the entire landscape of Massachusetts for more than 20 times the length of time since English colonists landed here. Now, on behalf of the National Park Service and Boston Harbor Now, I welcome you all to the second installment of our Revolutionary Harbor Lecture Series, Storms, Weather, and Climate in Boston Harbor. Tonight, we'll explore how weather and climate are related, but not the same, share stories about major historic storms in Boston, and discuss how these extreme weather events will continue to shape Boston Harbor and the islands in an era of rapid climate change. Now, I feel especially fortunate to be a little part of this evening's event, as I have a personal connection. My dad is the late Dick Albert, a longtime TV meteorologist here in Boston, initially a rival with tonight's first speaker, Harvey Leonard, then later a partner and a family friend. As I've grown into my own career, I've also been fortunate to work with and get to know our inspiring second speaker, Mark Borrelli. So we're in for a treat. I'd now like to introduce our moderator for the evening, Kathy Radonick. Kathy is a youth engagement specialist with the National Parks of Boston's Education, Youth, and Volunteer Engagement Team. Her work is focused on supporting Boston Public School students and their teachers in visiting park sites, as well as designing experiences and materials for classroom learning. With an education and research background in atmospheric science, Kathy is particularly enthusiastic about the opportunity to engage people, especially young people, in park stories having to do with weather and climate. Kathy, welcome and take it away.
Thanks, Mark. Hello, everybody, and welcome to our Revolutionary Harbor event. We have two great speakers for you all tonight, who I will introduce in just a minute. But before we get started, just a few housekeeping items to share. First, this program is being recorded. However, members of the audience will remain off camera and muted throughout the duration of the program until the question and answer session. So at that point, you'll be invited to, as members of the audience, to ask questions both verbally or using the question and answer function of Zoom. Everyone will at that time be invited to everyone will be invited to type your questions into the question and answer window as they come to you at any point during the presentation, and then we will also address questions separately at the end of both presentations. I want to also add that you can turn on, it looks like someone in the audience already has utilized the closed caption feature, but that is an option. If you'd like to use that, just check your menu bar at the bottom of Zoom, whatever device you're using. And we also just ask that you reserve the chat function for comments and or conversations with fellow audience members. And also, I invite everyone at this point to share a memory that you might have about a weather event in your past in the chat, just to kind of get us started thinking about weather, sharing with each other. So anything that might have been impactful to you over the years. Some may remember things from childhood, some later in life. So feel free to share in the chat a weather memory that you have. So without further ado, I'm going to introduce our two presenters today. Starting off, I will introduce Dr. Mark Borrelli, who's actually going to be our second speaker. Mark Borrelli is a coastal geologist and director of the Coastal Processes and Ecosystems Laboratory, or CAPE Lab, which is a joint research effort between UMass Boston's School for the Environment and the Center for Coastal Studies in Provincetown, Massachusetts. Dr. Borrelli has been the director of the seafloor mapping program at the center since 2009, where he's led over 200 vessel-based acoustic surveys in shallow nearshore waters. He's also a researcher with the Stone Living Lab, which is a collaborative initiative for testing nature-based approaches to climate adaptation, coastal resilience, and ecological restoration in high energy environments like Boston Harbor Islands National and State Park. Dr. Borrelli's research interests include coastal sedimentary processes in general and understanding how storms, sea level rise, and anthropogenic alterations affect the coast in particular. He received a bachelor's from Tufts University and a master's from the University of North Carolina at Chapel Hill, and he has a PhD from the University of Rhode Island. And now our first speaker, Harvey Leonard, is WCVB Channel 5's Chief Meteorologist Emeritus. Harvey has more than 45 years of experience forecasting weather in New England. 20 of those years has been a broadcast meteorologist at WCVB's Storm Team with WCVB's Storm Team 5. He is the recipient of many accolades and was inducted into the Massachusetts Broadcasters Hall of Fame in 2018. Harvey is also credited as the first meteorologist to correctly predict the impact and intensity of the infamous blizzard of 1978. He received a Bachelor of Science degree in meteorology from City College of New York and earned a Master of Science degree in meteorology from NYU, New York University, where he also served as an instructor in meteorology for a while. So without further ado, I am going to hand it over to Harvey Leonard to begin what he has to share with us tonight. Oh, Harvey, you're muted.
There we go. Okay, sorry about that. Kathy, thank you so much. It's a pleasure to be here this evening and to share this evening with you, of course, and with two Marks, of course, Mark Albert and Dr. Mark Borrelli. And of course, looking forward to what he is going to be showing us today as well. So I'm going to be talking a little bit about weather, climate, the difference between the two, and we'll be looking back at a couple of very significant storms from the past that some of you will remember if you're old enough, and some will not, but I think it will be helpful to see that. So we're going to do this with the help of some slides. So I think we're all set to get started. And as I said, first thing we really want to talk about is basically weather. Now, of course, we know about weather. Weather is, what we're experiencing outside. So we can just go to the next slide and you'll be able to see that when we talk about weather, it could be rainy, it could be snowy, it could be sunny, it could be cloudy, but this is all weather, whatever type of weather that's going on right now. And as a forecaster and a meteorologist, of course, I'm always focused on what the current weather is locally and what's going to be happening over the next 24 hours all the way out to about a week. So in our next slide, you will see what a meteorologist typically is doing on television. In the upper left, that was some bitter cold weather that I was once talking about. On the upper right, it was a significant snowstorm, obviously. Cindy Fitzgibbon, who is the current chief meteorologist at WCVB, is on the lower left. She was talking about the forecast and that for the afternoon. And then what you see a lot is the 7-day forecast. Okay. Now, all of that, though, is still part of weather and weather forecasting. But as we go to our next slide, we're going to start to show you the difference between weather and climate. When we talk about the average weather over a long period of time, that is our climate. And it's very important as to what our climate is doing. And there's certainly extremely strong evidence that our climate is warming. The graphic you're looking at here is showing you between 1991 and 2020, that 30-year period, what the temperatures were averaging compared to 1980 to 2010, going back 10 years. So that's how we do this when we talk about the average temperature in Boston for a given day. It is comparing it to that 30-year period. And if you'll notice, every single month there was a warming. No month was there a cooling. There were 2 months, March and November, that didn't show a significant change. Interesting that 2 of the winter months, December and January, had the biggest change on the warm side. In the summer, it was still there as well, not quite as much. But then again, we have to realize that the range in temperature is larger in the winter in the first place than it is in the summer. But that is suggestive, of course, of our climate warming. So let's go to our next graphic, and we'll be able to show you a longer time frame. We're talking about from 1900 all the way up to just about the present. And what you'll notice is there was a period where there was some cooling, 1901 to 1930. Then it kind of leveled out. And in the recent 50 years, it has solidly been warming. And notice the rate of warming is increasing. And that is very concerning. Now, some people might say, hey, our climate's always been changing. Normal climatic variation. That's true. But it seems that in addition to that, the whole idea of increased greenhouse gases is showing up more and more in the data. So let's go to our next graphic. And in that, you're going to see the blue line. That's showing you the amount of carbon dioxide parts per million. Look how that has been increasing. And of course, it's been increasing more and more. Ever since the Industrial Revolution, we've seen that. The burning of coal, oil, natural gas, one of the byproducts, carbon dioxide, goes up in the atmosphere. It's a greenhouse gas. It tends to trap heat. And if you look at the temperature, and that's the pinkish line, even though, of course, we have variations as we go along, but if you look at the average of that, it's directly proportionate to the increase in carbon dioxide. That is highly, highly suggestive of global warming, anthropogenic global warming that human beings are responsible for. All right, so let's go to our next graphic. And this is very concerning. Look at the changes in sea level, and then look at what has been happening of late. The sea level is rising. That's extremely important. Think about our coastline. Think about Boston Harbor and the islands and the entire coastline of Massachusetts. Sea level is rising. So that means even if storms of the future were similar to storms of the past and present, the amount of coastal flooding and beach erosion could be greater because sea level is rising. So that is a problem. And the storms themselves may be getting a little bit stronger, which we'll talk about. So that's a compounding factor. So let's go to our next slide. And here we'll be able to see that if you look at, higher tides are going to result in more flooding. We're looking at the number of U.S. coastal floods yearly and look at what is happening. Again, even though you have fluctuations, you can clearly see the average is going up. So higher sea level, that's one of the indications. And we're going to be talking about storms in a moment as well. So let's go to our next graphic. And here you could see the oceans heating up. I mean, this is pretty clear. Anything in a yellow, orange, or red color is showing you the oceans are getting warmer. That's the ocean water temperature. A lot of the heat is going into the oceans. And warmer ocean waters, that provides more energy for storms, coastal storms, tropical storms, hurricanes. So now if you have rising sea level and you have stronger storms, that's a double impact to make the storms more impactful along the coast. And that's obviously a concern. You could see a few little blue areas because we know that some of the ice caps and glaciers have been melting. So that can, make things a little bit cooler in the waters near there, but overall, temporarily, but overall, it's clear what's happening in the oceans. So we'll go to our next graphic and we'll be able to see, this is pretty basic. Warmer air can hold more moisture than cold air. So a warmer world is a wetter world by definition. And for every degree increase in temperature, there's a 4% increase in water vapor. And remember, when that moisture condenses and gets released, that's precipitation. And so we expect that we're going to have more frequent heavy precipitation occurrences. In our next slide, you'll see what's actually been happening here. There you go. This is showing you the increase in heaviest precipitation events throughout the country. But look where it's greatest. It's here. Why might that be? Well, for one thing, we're at such a latitude where the battle of warm air masses and cold air masses meet. Cold air from Canada, warm air from the south. And we have this huge moisture source to our east, the Atlantic Ocean. So we know with warmer ocean waters and a warmer atmosphere, there is more moisture available. And that is already showing up. This takes you from 1958 to 2016. So we'll go to our next slide and we'll be able to see when we talk about what's been happening, all types of weather. So we're seeing more heavy precipitation events. When it's cold enough, that can mean even slightly stronger major snowstorms. That happened, by the way, even though the temperature in Boston, the average temperature has been going up, the average snowfall actually went up as well. May not stay that way forever. Part of the reason is the jet stream. Because of the warming, which has been most notable in the high latitudes, it's affecting the jet stream and it's allowing some more stronger mid-latitude storms. So it's very interesting that at least for now, Boston's average snowfall, don't count this winter, that doesn't count. It counts, but that didn't do it, of course. But it's been going up, but the average temperature has been going up as well. So we're getting more flooding. In the lower left, you know, more weather extremes. That means more droughts. It also means a worse fire season out west, which we've been seeing as well. Now they've flipped and gone to some very, very big storms this winter. And of course, tropical storms and hurricanes. The feeling, by the way, based on the research I've seen, not necessarily that there'll be more hurricanes, but there may be more slightly stronger hurricanes because of the warmer ocean waters providing additional energy. So let's go to the next slide. And what we're going to see is this. We're going to start talking about the storms now. Now, on your left, that was Hurricane Bob as it approached. And that is the last hurricane that actually made a landfall in New England. It moved very close to Newport, Rhode Island, very close to Norwell, Massachusetts. And to the east of that storm was where the winds were bad and the storm surge, and to the north and west where the heavy rain was. But if you look at the right, that is an example of what major snowstorms and blizzards can do around here. So I want to go over a few of these storms, and we're certainly not going to cover all of them, but we can go to the next slide, and you'll be able to see that we're talking about hurricanes. Now, hurricanes can take a lot of tracks. They form sometimes off the coast of Africa. Down there, the easterlies prevail, so they tend to move from east to west. Now, when they get in position close to the Caribbean, close to the Bahamas, they could sometimes continue to go west, maybe hit southern Florida or the Caribbean or the Gulf Coast. They could curve and maybe go toward the Carolina coast. If they curve a little more sharply, they can come up to us here in New England. If they curve even more, which we don't show in the graphic, then they'll recurve out to sea. Maybe Bermuda would worry about it. Okay, so those are some of the different paths. Now, as we go to the next slide, we're going to show you that some of the paths that occurred, there were about 74 hits just between 1950 and 2011 around either southern Florida or the Gulf Coast. But in our next slide, you'll also see that there was a significant number of storms that went up toward the Carolinas and made hits. And in that time frame, yes, we had some hitting New England as well. So in our next slide, you'll see the ones that come straight at us. And this is the difficulty, because if you take a storm from the Bahamas, turn it north, the next place or first place it can make a landfall, Long Island, New York, or the southern coast of New England. So we had 6 direct hits between 1950 and about 2011. Now, I want to go to the next graphic, because what we're going to show you now is one of the most impressive storms ever. In fact, this is the greatest natural disaster ever for southern New England. It was the hurricane of 1938. Now let's go to our next slide. Since most of us who are seeing this were not alive at the time, this was the infancy of weather forecasting. At that time, what was thought is most of those storms tend to recurve out to sea. So it actually went north, it accelerated, it came into Long Island and New England. It only took 6 hours to get off the coast of North Carolina into the south coast of New England. And when it moves that fast, even though our ocean waters are a little cooler, it doesn't have much time to weaken. So that was a worst case scenario. So in our next graphic, you're going to see the track it took. The center went right up the Connecticut River Valley. However, the counterclockwise flow around a storm brought a southeasterly wind, very powerful, right onto the shoreline, especially the south coast of New England. Okay, so in our next graphic, I'm going to show you what the winds reached. Now, this is up here. So if people don't think we can get powerful hurricanes, we had a wind gust to 186 miles per hour atop Blue Hill, which is elevated by 600 feet. and that's in Milton, Massachusetts, 10 miles southwest of Boston. Now, back in 2003, Dick Albert and I had the opportunity to do a special and take a look on the 65-year anniversary of the hurricane of 1938. And here's an excerpt from that.
On Monday, far to the south, newspapers reported a major hurricane was only 24 hours away from the South Florida coast. But on Tuesday morning, it was reported with great relief that the storm had veered north, heading out to sea. The National Weather Bureau received congratulations from the New York Times for tracking the storm so well. Overnight, the hurricane was off Cape Hatteras in North Carolina. The Weather Bureau assumed it would continue out to sea, but the storm turned inland, found a narrow passage, and hammered due north. Amazingly, within 6 hours, the 38 hurricane was here.
Since the Okay, so that's an excerpt from the hurricane of 1938. Look at this toll. I mean, people did not know what hit them on the south coast of New England, especially southern Rhode Island. 564 deaths, 1,700 injuries. I told you about the gust atop Blue Hill. The sustained winds reached 121 miles per hour and 20 feet of water in downtown Providence. Since that storm and the ones in the 50s, because there were more hurricanes, Hurricane Barry was erected around New Bedford to try to prevent that surge of water up Narragansett Bay in Rhode Island. There are three keys to southern New England hurricanes. Obviously, the intensity is important. The track is extremely important. The most dangerous is when they track just to our west. Then we wind up on the dangerous side for storm surge and wind. The motion and forward speed is extremely important. If it's moving slowly, then it will have a chance to at least weaken some when it gets above the latitude of the Carolinas and the ocean water temperature drops below 80. But when it's moving and accelerating, that's the worst case scenario for us. All right, I wanted to now next show you in our next slide, as we continue to talk about these storms, we're going to shift gears and talk a little bit about a winter storm. Now, this is a meteorological weather map taken up around 20,000 feet. And you're seeing this big low pressure area, a lot of closed lines, which means a lot of wind. But of course, we live down on the ground. And what we care about is what happens on the surface weather map. So this was the blizzard of 78. It was my first winter forecasting in Boston, but I had forecast 3 winters in Rhode Island prior to that. And prior to that, he had just come out of graduate school at NYU. Had an unbelievable professor, Dr. Vinnie Cardone. And there was a lot of theoretical information to learn, but there was no practical weather forecasting course. And I spoke to him about it. And I said, you'd be great teaching it. Why is there not a course? Because I knew that was my area of interest. And he said, you know what? Get a petition started, get enough signatures. I'll be happy to teach it. I got 9 signatures. He taught the course and I learned so much. And what I learned in that class actually came into play in my forecasting leading up to the blizzard of 1978, because we learned that when you have disturbances, cold pockets of air at high levels of the atmosphere that are very strong, they move into just the right position toward the mid-Atlantic coast, you're going to get a storm development down on the ground. So it's almost driven from the top down how it all develops. But not the earlier generation of meteorologists really had known that too much at that time. So there was a bit of an advantage really for me in forecasting that. But let's go to the next graphic, because I want to show you a few more things about this. All right, about other storms, because we're going to get back to the blizzard of 78. But these are just some of the big coastal storms that have affected us. There was Christmas night in 1909. There was severe coastal flooding. Valentine's Day storm, big snowstorm in 1940. In March 1956, there was a blizzard. There were 4 snowstorms in 10 days in March of 1956. February 1969, a storm stalled. It was known as the 100-hour snowfall for Boston. The blizzard of 78, which we're going to talk about more in a moment. October 1991, that's what became known as the perfect storm. December 1992 was a vicious nor'easter and coastal storm. One we didn't include in there was also in March of 1993. That's a storm that became known as the storm of the century for the eastern quarter of the country. It wasn't the storm of the century for us, but it was very impactful. A lot of stream flooding, October 1996. April 1997 was the April Fool's storm, 25.4 inches of snow in Boston, and it was in April. And January 2018, one of the most recent storms that caused a lot of coastal flooding around the seaport in Boston. So it is definitely a concern. But let's go to our next graphic, and we'll show a little bit more about the blizzard of 78. That's everything backed up on Route 128. Early in the storm, a couple of tractor trailers jackknifed near the Route 138 exit in Canton. Everything got backed up. Then the snow piled up. Unfortunately, I think we lost about 14 lives on 128 because some people left and knocked on strangers' homes. Other people stayed in their cars, ran the engine occasionally for warmth, but once the snow got above the exhaust system, carbon monoxide poisoning, terrible tragedy. So let's go on to the next slide for the blizzard of 78. This was the setup. Bitter cold, high pressure area. The temperature was near zero leading into the storm. We had one of those Alberta clippers coming down out of Canada through the upper Midwest. In and of itself, it wouldn't be a big deal. But once that energy, as I showed you, at high levels of the atmosphere approached the East Coast, a second storm formed just north of the Bahamas and raced up the coast, bumped into the bitter cold air, and it was a classic setup. So let's look at our next graphic, and we'll be able to see what we're talking about. So there you could see the powerful easterly winds with enough cold air in place, and the storm wound up stalling, and it was just an epic storm. So also in the special that Dick and I did, I believe, we have an excerpt from the blizzard of 78.
Going to happen is a tremendous amount of energy in high levels of the atmosphere pouring down to the southeast will really enhance the development of this storm, and that's the one that we expect to come up the coast in a fashion something like that. With all the cold air that's over us now, unquestionably the bulk of this storm has to be in the form of snow. We think it's going to be a big one of the biggest of the winter. The only way we can see being wrong is if this storm takes a radical turn left, then perhaps some warm air from the ocean would come in. Even if that happens, which I rate a long shot, we'd have to have an extended period of snow first.
The whole house was shaking, and the water started coming in. When I left, there was about a foot of water in the house. I thought the place was going to come down.
I stayed Monday night till about 6:30, and then the oceanside door blew in, and then when I was trying to reinforce that, the picture windows blew in, so I grabbed my kids and I had to run for my life.
North and south along the coast, discomfort and inconvenience gave way to destruction and tragedy. The wind, gaining strength far out at sea, built an already high tide to a wall of water, smashing through Revere, Winthrop, Scituate, Hull, killing the few, sweeping away homes, displacing 11,000, damage in the hundreds of millions, wiping out past lives in a sweeping flood, threatening the lives of those who live on her.
It was a horror scene to see the Atlantic Ocean streaming into your backyard and onto the side streets. It was truly a horrifying experience.
Okay. By the way, in the video that you just saw at the beginning of it, I know it's hard to believe, but that actually was me back in 1978. And I know what you're saying. Oh my gosh, what can happen to a human being? But that's okay. But in any event, getting back to the serious nature of it, you could see that it was a multifaceted storm. Of course, to people not near the coast, it was just the immense amount of snow, and you can see all the stranded vehicles on 128. But for those along the coast, I mean, you can't call that a hurricane because a hurricane is a warm core storm, and this was built by the change in air masses, cold and warm clashing. But the winds were strong enough to actually qualify. So it was almost like getting the winds of a hurricane and all of that snow on top of it. But that's the picture of all the snow there causing all that backup on 128. Now we'll go to the next graphic. And here again, this was the setup. So we had this disturbance just north of the Great Lakes, and it was diving southeastward. This was what's happening 20,000 feet up in the atmosphere. Go to the next slide, and you'll see how it's dropping down to the southeast. Notice if it keeps doing that and cuts just under us toward the mid-Atlantic with cold air in place, that's the classic setup. In the next graphic, you'll be able to see that that's exactly what happened. And when these things, you see all those lines around it, it cuts off from the flow of the atmosphere. It almost becomes its own entity. And this stalled on top of it. So it wasn't only powerful, it was a long duration. We go to the next graphic and you'll see when the storm was really reaching its peak. And when it got in that position, it didn't move very far, very fast. And we were continuing to get all that massive, powerful easterly wind, huge waves, big storm surge before high tide cycles. And that was just too much for a lot of the coastline to withstand. Let's go to our next graphic. As I mentioned, when the storm got into place like that, it didn't move very much. So you could see it's still there. And in fact, it only ever so slowly meandered eastward. So all of its development, intensity, maturity of the storm happened a little below our latitude. We were in range. Sometimes these strong storms affect us, but they keep moving up to the Canadian Maritimes. But here we got everything from its inception to its intensification to its maturity until finally it drifted away. So there's a lot of interesting stats that came out of this as we go to the next graphic from this particular storm. We call them blizzard bits or tidbits. So the tides were about 4 feet above normal, but it was a new moon. And the tides were high in the first place because of the gravitational attraction of the Earth and the moon. And of course, it's strongest at new moon and high tide, new moon and full moon. So you had that, and then you had huge waves on top of that storm surge. And there aren't many forces in nature more powerful than rushing ocean water. So at the time, it was the only blizzard in Boston since 1961 that had sustained winds of 35 miles an hour for 3 hours or more. That made it a blizzard. There have been some since, of course. And there you see it. Boston had a wind gust to 79 miles an hour, Chatham to 93. And the total cost of the damage was estimated about $1 billion. 99 lives were lost. And it was just a catastrophe along parts of the coastline. Let's go to our next graphic. And we'll be able to see what's happening. Now, all the Boston Harbor Islands are very important. And Dr. Mark Borrelli is going to talk much more about this. And they play a part as to which parts of the coastline receive the worst of the worst damage. Also, when we talk about these powerful winds and storm surge, you know, the easterly winds, how many miles, how many hundreds sometimes of miles are they passing across the ocean to allow the winds, and the waves to build? That's very important. We call that fetch. But that's Dr. Mark Borrelli's strength, one of his many. So he'll be talking about that in a moment. All right, let's go to the next graphic. I just want to illustrate the difference. Of course, Quincy Bay was hit hard and Wollaston Beach. You see that, and you see all the snow. But when you compare that to other coastal communities, it's like night and day. Let's go to our next one, and you're going to be able to see what happened. And look at this in Revere. I mean, it was just devastating. You would think a hurricane came through the region. And that's not the only coastal community hit so hard. As we go to the next one, you'll be able to see what happened down in Hull, which took the brunt of the storm through 4 successive high tide cycles. Several days after the storm, I was doing a special live around 7:30 in the evening with one of our reporters, Mike Levitt. We were in Hull, and the seawall was just broken up into blocks, chunks, and moved and everything. And you realize the force that is required to do that. So it was just unbelievable. There was like 5 feet of slush in the streets of Hull and Scituate, combination of the heavy snow and of course the waves and the storm surge coming in. Just unbelievable. All right, let's go to the next slide. And this is Peggotty Beach, Scituate. Similar story, a major damage. I think, if I remember correctly, about 10,000 homes along the coast were severely damaged, and about 2,000 were completely destroyed. So, and of course, the power outages and the damage and all the debris and all that, it was just immense. Okay, so let's go to the next graphic. And that gives me the opportunity to thank you for watching and listening. And now it's my pleasure and my honor. Just before I throw it over to Mark, I wanted to throw one last climate thing at you. You know, we had a day, February 4th this year in Boston, that was 10 below zero and the coldest day in 57 years. And you might say something like, Hey, when that happens, Harvey, where's climate change when you need it? However, that's one day. That's weather. That's not climate. If we look at the entire winter, even the month of February was warmer than average. The entire winter was over 4 degrees warmer than average. So that again is an example of the difference between weather and climate. And now, Mark, it is all yours.
Harvey, thank you so much. That was a really great talk. Thank you so much. Yeah, I don't know. This might have been a huge mistake going on after Harvey Leonard. I don't know what I was thinking. This is like going on after Bruce Springsteen or something. I don't know. We'll see. We'll see what we do. Okay. I'm not sure. PowerPoint. Okay. Let's see. Of course, my PowerPoint's not working. I'm going to stop sharing just for 1 second and try that again. That's fun. Okay. Having a little technical difficulty, folks. Please bear with me. And okay. Can't. So just gonna stop that. Sorry, folks. So I'm just gonna start mine back up again, but everything should be fine. So actually what I can do is I can tell me a Harvey Leonard story. Everybody who pretty much grows up in New England has a Harvey Leonard story. When I was a kid, my brother came in on the night of the blizzard in 1978. I was like 7 or 8 years old. My brother came into my bedroom and said, Harvey Leonard just said there was going to be a wicked big storm, so we're not going to school tomorrow. Now that's not what Harvey Leonard said, but that was the effect of it. It was really, really interesting. And Harvey was always interesting to watch, and he always, as you just saw, just really communicated very, very well. So that was really a pleasure. So I'm going to see what I can do here to follow up Harvey, but we'll do the best I can. First thing is, what we're going to do, we're going to talk about Boston Harbor, because this is about Boston Harbor. Then I'm going to talk about climate change and sea level rise, and Harvey already started to talk to us about that. And then we're going to follow up with a little bit about coastal storms as they relate to climate change and sea level rise. So the first thing we want to talk about is, some of these climate change projections we're going to talk about tonight are dire, right? This is going to be tough to deal with, but we're going to get through it, right? We're going to figure it out, and we're going to be able to do this. And it starts with data, right? We build with data, and then we construct the data. We use science to help us understand it, and then we develop this policy, right? And the main things that I'm concerned about, or scientists are concerned about, is how we deal with uncertainty, how we deal with perception, because it's a big issue going forward, and creeping normality. Now, this is a term that Jared Diamond came up with, or popularized in his book, Collapse: How Societies Choose to Fail or Succeed. And I think maybe we can add creeping climate normality. This is tricky, especially for younger people, because the odd weather patterns that we're seeing that lead us to believe or reinforce the idea that climate change is actually happening is normal for them, right? If you're 15, 20 years old, 10 years old, this is normal. It's not that unusual. When we talked about the blizzard of 78, when I lived through the blizzard of 78, when I was a kid, when you finally got snow around here, and I was born in Malden, Massachusetts, just 5 miles north of Boston. When you got snow in January or February, it didn't melt. It stayed here for a long time. It stayed here for the bulk of the winter. We didn't have a situation where it would warm up into the 50s and all the snow would melt. When we got that snow in 1978, it stayed there for the rest of the winter. So this is an issue that we really need to, this is the thing I'm most concerned about, to be perfectly honest, but we'll talk about it as we go through. First thing though, we're gonna see some data. We're gonna see some quantitative data. So I just want to make sure everybody's on the same page. And usually I ask for hands. I won't do that. But if I say things like, which one has the steepest curve here, right? Which has the steepest slope? Is it A, B, or C? Because we are going to be talking about quantitative data. So I just want to make sure everybody's on the same page. So take a moment. A, B, or C for the steepest slope. Okay, they're all the same. These are the same images, and all I did was stretch out B or C, right? You don't have enough information to decide. You don't have enough information to know which one is the steepest because the units aren't shown here. So I'm sorry I play a little trick on you, but it's important to understand that you think you have the information that you need to make this decision. You don't necessarily. So it's something that's going to come back again and again during the talk, and quite frankly, it's something that's going to come back again and again as you move through the next 10, 15, 20 years of understanding the science that people are putting in front of you. Context. When we talk about Boston, we talk about New England. 20,000 years ago, there was an ice sheet here covering all of Canada and the northern parts of the United States. And it changed, this was climate change, right? This is a natural climate change that happened over many, many thousands of years. In Boston, again, for context, we had an ice sheet that was 1,200 meters thick, right? This is about 3/4 of a mile. Now we have to imagine that for a second. We had an ice sheet in Boston that was 3/4 of a mile thick. Sea level was about 300 feet lower than it is today. So there is a lot of natural variability, but it happens very, very slowly, or it used to happen very, very slowly. And I find sometimes when people say things like, you have, sea level used to be much lower in the past, 300 feet lower in the past, and it was even higher way back millions of years. It was 100, 150 feet higher. And maybe all this climate change that's going on now is variability. Maybe the scientists don't really know. So my response to them is, okay, you say that the sea level was 300 feet lower about 20,000 years ago. How do you know? You know because scientists told you. You know there's natural variability because scientists have told you this based on their studies, based on the publications, based on the literature. So it's really difficult to use that and cherry pick the information you want to prove this point now. As Harvey said, it's very, very, we have a huge amount of data that leads us to believe that climate change is occurring. Anthropogenic climate change, human-induced climate change is occurring. We look at what we call the Laurentide ice sheet, that ice sheet that covered most of New England. And it's slowly, these are thousands of years, and it slowly expands and it moves down to southern New England. The most seaward extent, southern extent, was around Martha's Vineyard and Nantucket for New England. And then it starts to recede and it starts to melt. And again, this is a huge amount of ice, right? So this is a lot of melting going on. 9,000 years ago, where Boston Harbor is now was dry, right? The water started to come in about 6,000 years ago, and about 3,000 years ago, we're getting close to where the present day shoreline is. And all the features that we see in Boston largely are formed by the glaciers receding, by the glaciers melting. We see these beautiful islands in Boston Harbor, and I can tell you, having been out on the islands, one of the best ways to see Boston skyline is from the islands. You get out to the Boston Harbor Islands, they're gorgeous. But a lot of these are drumlins or remnant of drumlins. And drumlins are features, they're these oval shaped landforms. They're composed of sediment that form beneath the ice as it melts. And it actually gives you an indication of which way the ice was moving as it was melting. So there's been a lot of research done on this. All of these little ovals are the shapes of the drumlins. And of course, they've been manipulated and they've been eroded, naturally eroding. We've changed them. There's only 3 instances of a marine inundation of a drumlin field in the world. It's in Iceland, Ireland, and here in Boston. Actually, the word drumlin is actually an Irish word. I think it's little ridge, small ridge. But these features are rare, but they're really unique. We're very lucky to have this resource in Boston Harbor for a number of different reasons. Again, they provide all kinds of benefits in terms of recreation. They've been used for Army forts, all kinds of installations. Right now, of course, we have this wonderful Boston Harbor Islands, the National Recreation Area. The other thing that's really useful, or one of the other things that's really helpful, is that they also attenuate wave energy. And this is what Harvey was talking about. If there were no Boston Harbor Islands, and this was just an open basin, the wave energy that got into Boston Harbor on the mainland shorelands would be much, much higher. So this is a wave model that was done. And out here during, this was modeled after a nor'easter, a moderate nor'easter. You have 7-foot waves. And as the water gets shallower, the waves start to come down. But as soon as you get into Boston Harbor, the waves are gone, right? The waves go right down really rapidly, 3 feet, 4 feet. So what you see along the mainland shoreline is that they cut down waves substantially, which is really important. Obviously, it reduces the amount of erosion, the amount of damage, loss of life, and things like that. So understanding how these islands, all the benefits these islands provide to us, helps us appreciate them more and gives us a better indication of how to manage these going forward, right? So that's something to keep in mind as we move forward through this, because Boston, as you know, is very low lying. We have the king tide. Now, this is a term. It's funny, not a lot of people know this, but king tide was a term that was just invented in Australia in like 2005, 2006, and it's stuck. It's a king tide. It doesn't really mean anything. It's just descriptive. It's some of the biggest tides of the year, but these are perigean spring tides when you have the new moon and the full moon. But a few times a year, they get extra high because of the relationship between the moon and the sun and the earth. And you have these king tides. And in Boston, we have quite a bit of flooding that goes on in these low-lying areas. We see it frequently. And again, king tide is not the best term. This is Boston. Let's show our pride here. We should call them wicked high tides, a much better term. The king tide is just confusing. I never liked king tide, but wicked high tide, there you go. But they are perigean spring tides, is what we scientists call them. Now, Boston in and of itself is an odd place for people who don't know. This is the landform that that we found when we first got here, right? When people came to Boston, this is the land that we found in gray. Everything else was filled in. Everything else you see here was filled in. When they first got here, it was all water, right? So we've done an enormous amount of alteration. Now, for those of you who talked to some of the folks in the chat talked about Hurricane Sandy, Superstorm Sandy, and some of the most damaged areas in Manhattan and in New York were low-lying areas that were filled, marshlands that were filled, Back Bay areas that were filled. If you look at Boston and you look at the FEMA floodplains, now of course the bodies of water are highlighted here, but look at all the areas that are in the floodplain that were filled. So we have these filled tidelands in Boston, and not unsurprisingly, these are some of the places that are going to experience the most amount of flooding. So this is what we have. This is what we have to deal with. So that sort of sets the stage for us. I want to talk a little bit about climate change and sea level rise. And yeah, it's easy to pick on the media, so let's do that. This is a study. There was a study that came out in February of 2022. It was a very important study, and it's a very good study. But it's always interesting to see how the media talks about these things. So the New York Times said that coastal sea level rise in the US to rise by a foot by 2050. Well, that's not what the study said. The Boston Globe said that Northeast is likely to experience more than a century's worth of sea level rise from 2000 to 2050. That's much better. So, and this is important stuff. So this was the study, and I want to talk about it just for a minute, because the key message, right? The key message that we talk about in the executive summary, multiple lines of evidence provide increased confidence, okay? Provide increased confidence, regardless of the emissions pathway, in a narrower range of projected global, national, and regional sea level rise by 2050. This entire report, a big part of this report, was about reducing the amount of uncertainty, which is really important, right? It's a huge effort. And they looked at national, regional, local sea level, and they were able to, through a lot of updating the previous reports, doing more analysis to really clamp down on that uncertainty. So that's really, it's a wonderful story, and it's really important. The problem comes when and if you read the articles, they're much better. I will say that the articles are much better, but the headlines, the one in the New York Times, this study did not confirm that there's going to be a foot of sea level rise by 2050. It just didn't. It said it's much more likely, right? So we have to dig deep sometimes into the reporting that we're seeing to get down to the story. And most of these scientific reports, while they're out of reach for most people who can't, who don't do these things, executive summaries are really good. They're written for the general public, and everybody should read them. just as I did right there, because I think it's really helpful. Now, Harvey touched on this too. We're going back in geologic time here. We're going 400,000 years into the past, and we're going to look at the relationship between temperature, which is in blue, and carbon dioxide, CO2, which is in red, right? And this was taken from an ice core in Greenland. There's a wonderful book called The 2 Mile Time Machine, where they talked about how they did this in the mid to late 90s. But they were able to go back even further than the 400,000 years. But these data are fantastic. You're not going to see a better relationship when the CO2 peaks, a little while later, the temperature peaks. CO2 peaks, temperature. And same thing on the troughs. When you have a bottoming out of the CO2, you have a bottoming out of the temperature, right? So this is a really, really nice data set. These two data sets are related, right? Obviously. And it's very easy to say that there's a causal relationship here too when you see these kinds of data sets. But the thing we want to talk about tonight is this line. I didn't draw this line, right? This is the line on the map, a vertical line, right? This is what we're looking at here. Now, this is an old figure. These data are from the 90s. It was updated in the early 2000s, but we're going to update it until the very last month of data, February 2023. We now have 420 parts per million of CO2 in the atmosphere as of February 2023, the last month, obviously, that we have data. So this continues to go up. And it goes up at a rate that we've never seen before. So this is a concern. This is why we're talking about this stuff. Now, I hear people say this, they can't predict the weather next week. What do they know about climate in 20 years? And I usually develop some kind of facial twitch. This really gets me frustrated. Now, and there's a number of reasons why, but this figure, I love this figure. In 2014, 2013, they went back and looked at all the predictions they made, the IPCC, Intergovernmental Panel on Climate Change. And they went back to 1991, the first report. And they said, okay, we had our tide gauge data from the 1970s to 1991, and then we made our predictions. How did we do? Well, the gray here is their predictions from 1991. The red and the blue is what actually happened. Okay, we have sea level change on the y-axis, and obviously time on the x-axis. The predictions were in the gray, and the actual data that they measured from tide gauges and satellite observations were at the high end of that prediction. Now, this was a model and a computer from 1991. The computer they used in 1991 was not nearly as powerful as the phone you have in your pocket, right? The computers have gotten more powerful. The models are getting better. We're really good at this. We're very, very good at this. This is the same kind of thing with CO2, right? Not sea level, but the amount of CO2, the different color lines of the different scenarios of predicting how much, unfortunately, how much CO2 we think we would emit or emit into the atmosphere. And again, this pink triangle here is the range of uncertainty for all the different scenarios. And the black dotted line is the actual measurements. So we made this prediction in 2001. We went back in 2012, 2013, and saw how we did. And we did really well. So we're pretty good at this. Now, this one is a messy one. This gives all the different scenarios and all the different model runs. And that's why it's so noisy. But what I'm going to do is I'm going to zoom in again. This is CO2, but I want to zoom in on this chart. So this is where the predictions started when they first did the report. The black line is what actually happened up until the end of the report. Again, it's at the red. It's at the highest prediction. And it's, of the four models, it's at the highest prediction. So this is a 2014 report. We're good at this. And unfortunately, we always seem to be at the high end of the predictions. Even sea ice. Now, sea ice is really important. The loss of sea ice is very important. So what we want to do is we want to look at how much we've lost. And again, if we go back in that time, the initial model that predicted, the black line is the actual observed. And on this one, unfortunately, we're at the low end. And the low end is not where you want to be. Same kind of thing here. So we predicted to the future. I want to talk a little bit about global versus relative sea level rise, because we're going to talk about that now. When we talk about groundwater changes or subsidence and uplift in ocean currents, that's a regional effect. right? So that has to do with relative, that can change the relative sea level rise or the rates of relative sea level rise. When we're talking about temperatures or melting glaciers in Iceland, in Greenland and Antarctica, that's a global impact. That affects global sea level rise. So when you see these numbers and these predictions, you have to understand whether they're making a prediction for the global sea level rise or the relative sea level rise. That's very important. So this is Boston. We have a really good tide gauge here. It goes back to the 1920s. And you can see this gradual increase here. The rate is about, over the last century, we've seen about a foot of sea level rise in Boston, relative sea level rise. This is Louisiana, much higher. And again, this is relative sea level rise. So the global sea level rise is the same. Obviously, it's global sea level rise. But what's happening here is the land is subsiding in Louisiana, right? So the global sea level rise is occurring, but the land is decreasing in elevation. So you have a greater rate of relative sea level or regional sea level rise here. And that's why that's different. So just go back to Boston and to Louisiana, much, much different. Oh, do I have the slide upside down? No, wait. Always good to throw in a curveball here. In Skagway, Alaska, there's actually sea level fall. Yes, sea level fall. How is this happening? Remember, we talked about the relative rate of sea level rise. We also talked about ice sheets. And in Boston, the ice sheet was about 3/4 of a mile thick. In Alaska, it was almost 5 miles thick. So what happens is when you imagine yourself getting on a raft in a pool, right? That raft sinks down a little. And then when you get off the raft comes back up. Well, this ice sheet pushed the crust of the earth down and because it was so massive and so dense. And then as the ice sheet starts to melt, the land actually rebounds, isostatic rebound, and it comes back up just like the raft does. And it's still rising, and it's rising. The land is rising so fast in this part of Alaska, there's actually relative sea level fall. Yeah, I know. That's a tricky one. But the trends are clear, right? And again, if you hear someone say, well, in some parts of the world, this actually sea level is falling, there's a reason, right? Look into the data, understand why these things are happening. It's not uncommon, but it doesn't disprove anything else. This is a great website for people to check out. This is a NASA website, and it's very local. So you can put your mouse over and you can look at the different ranges of change. This is in feet, and they have predictions for 2030, 2040, 2050, all the way up to 2100. And you can see here, hopefully you can see my mouse looking over at this column here. They give you the contribution for all the different components that actually affect this. This is really interesting. So that's that vertical land movement we talked about, groundwater storage, the melting of the ice sheets and the glaciers, and the sterodynamic. This is the steric effect. The warming of the water actually causes water to expand. So that's actually part of it too. All right. So when we talk about the water expanding, when we talk about the sea level rise, we can expect these king tides, these wicked high tides to increase. And Harvey mentioned this earlier, the frequency of these is going to increase. The last little bit I want to talk about coastal storms, obviously Harvey really nailed it, but I want to talk about it in the context of climate change. This is Peggotty Beach. This is one of the ones that really got damaged in the blizzard of '78. This is from 2016. This is a rare occasion where the winds from the storm stopped, but the waves kept going. So they got a drone up in the air. And I just wanted to show this because this is just really interesting. Look at the amount of sediment that's been deposited at the wheels of this car. It's about 4 or 5 inches of sand. Now think about how much this barrier just increased in elevation because of one moderate storm, right? We said that the rate of sea level rise was a foot a century. Well, in one moderate storm, the elevation of this barrier increased about 4 inches. It's free sand. You've just spent 30 or 40 years of sea level rise, and it just got deposited on your beach for free. Now, unfortunately, people live here. Emergency vehicles have to come here. So the first thing the town's going to do, unfortunately, is plow this sand and move it somewhere else, which is too bad because this barrier, this is one of the ways that barriers keep pace with sea level rise. And it's just not allowed to because of different concerns. But looking at the power and the energy of a moderate storm, is really impressive. Storms don't always have negative impacts, right? The barrier, the low-lying lands are benefiting from this storm because the storm is actually allowing this landform to keep pace with sea level rise as the sand gets deposited. It's a beautiful, wonderful natural situation. And one thing I'll bring your attention to, I'm going to stop the video again right here. This is not the first row of houses. This is. The first row of houses are almost all gone. This is the second row of houses we're seeing here. That's the first row. And when Harvey showed that image of Peggotty Beach and blizzard of 78 getting damaged, those are some of the houses. Last couple things I wanted to talk about were when we talk about storm, a 10-year storm and a 100-year storm, we've got a quick quiz here. A blank foot rise in mean sea level would enable what we call a 10-year storm, which is a storm that on average occurs every 10 years, to flood areas that today are only flooded by a 100-year storm. So what's the difference between a 10-year storm versus a 100-year storm based on that elevation, that water level? And it's only a foot. The difference between water levels between a 100-year storm and a 10-year storm is at 1 foot. And what has been the average rate of sea level rise in New England over the last 100 years? About a foot. Okay, last couple things about storms. This is another really cool website you can go to. It's a NOAA co-op site, and you can look at actual storms, and I'm going to zoom in here. This is the January 2018 storm, and what we have here is the predicted tide in blue, the actual tide in green, and then the purple line is the difference between the two, and that's basically storm surge. So when did the storm surge peak? It peaked right at high tide here, right? And it stayed pretty high for a while. But remember how Harvey was talking about the blizzard 78 was up there for 4 high tides? This was only basically 1, right? So imagine that blizzard 78 was there for 4 high tides. This one, it came, it was powerful, and there was about a 3-foot storm surge here. That's our new storm of record, is the 2018 storm. Now, I want to show you, this is not uncommon. This is a storm from 2015, and it's the same kind of thing. We're going to mouse over, and it shows us the numbers. The storm surge here was 4.7 feet. This was a massive storm. A massive storm. But guess what? The storm peaked at low tide. You get about a 10-foot tide range on the Gulf of Maine coast out here, right? If you're in Boston or in Cape Cod, you get about a 10, in Cape Cod Bay, you get about a 10-foot tide range. If this happens at low tide, not much happens. But this was a monster storm. So much so that if you take the 2018 storm, which is our new storm of record, it had a total water level of 15 feet with a 3-foot storm surge. You take this storm, and again, this wasn't even that big of a storm, historically speaking, but you take that storm surge and you put those two together, 2015 storm surge, the 2018 water level, because it was a spring high tide, you would get a total water level that's 1.5 feet higher than the 2018 storm. 1.5 feet higher from a storm, just because of the timing. So what's the take-home message from this storm piece? Is that with rising sea levels, these kinds of things are going to happen more often because the timing is going to be right, because they happen more frequently. And if this was 6 hours earlier, you'd have it at high tide. And it would have been the biggest storm by 1.5 feet that New England has ever seen. So the last thing I just want to wrap up, these things are important, right? What we're talking about, I think perception, I think we're good. I think people get it. If people are paying attention, people understand that it's happening. We see these things happening. And we see the changes through time. Uncertainty, we're just getting better and better at this, right? We're making better predictions. Predicting of hurricanes has gotten much, much better. This is the tricky part. This is the creeping normality part. The younger people today don't see this as unusual, or might not see it as unusual. So we have to keep driving the story home. Every decade, my daughter was born in 2003. If you look at the 10 hottest global years on record, they're all since 2005. Same thing with the decades, even decadal. This is the new norm that Harvey started with, talking about this new normal. So it's really tricky. We have to be very vigilant. The higher high tides, this whole new normal is something that we have to focus on, and we have to pay attention to, and we have to bring this stuff, the science, the data, and the policy right into the center of what we're doing, and build around that. And I want to thank, it's been a joy working with Harvey, getting this together. The Stellan Living Lab, UMass Boston, Boston Harbor Islands, Boston Harbor Now. I really want to thank Mark, Albert, Brittany, and Kathy. Just a lot of fun putting this together, a lot of fun doing this. I wish we were all in the same room, but I know we're going to stop now and we're going to ask questions, and I'm really looking forward to that.
Thank you, Mark. And thank you, Harvey, for these two really compelling presentations. I know there's a ton of information out there. And, you know, even as someone who studied atmospheric science for, you know, almost 8 years, it can be overwhelming to parse through all of the informations. And you both really did a great job at presenting some really, really, you know, amazing graphics, information, and explanations. So thank you. And this is where we invite the audience to ask questions and pose questions to Dr. Mark Borrelli and Harvey Leonard, two great experts at hand here. We do have some great questions already in our question and answer queue. And the first one I will throw out, I think maybe Harvey, if you want to address this first, because it's a little more weather centered. But what are predictions for weather in New England and Massachusetts in the future with climate change? And how long before we see major changes, or are we already seeing them?
Yeah, well, I think we are indeed already seeing them, particularly in the winter. Now, you know, you have to do a scientific study. If you haven't done a scientific study, then what I say is just anecdotal, you know, what I'm kind of noticing, but it's not an actual research project. But I think most of us would agree who've been around for a while, we can still get very intense winter weather periods. We didn't really have that this year, except for the one bitter cold period, which was incredibly cold and incredibly fleeting. The turnaround from -10, you know, on a early Saturday morning to being in the mid upper 40s, maybe even 52 Sunday afternoon, that just would never happen. And I know Mark was talking about the idea, you know, remembering when you get snowstorms, and a good deal of that snow, or certainly some of it, is around for a long time. But it seems that it's very, very difficult now to sustain winter over a long period of time. The most recent example that was anything like that was the winter of 2014-15, when from late January into March, it was both incredibly snowy and incredibly cold. And Boston had 5.5 inches of snow for the season as of January 23rd, that year, 2015, that winter season, 2014-15 winter, and wound up with 110 inches, and had 4 massive snowstorms in less than 3 weeks, and it stayed very cold throughout that period. So it was one of the most intense winter periods we've ever had. But yet, meteorologically, we consider winter to be December, January, and February, because those are the coldest months. And we were more than 50% of the way through before winter really got started. So it still wasn't a full, long, continuous winter. I can remember several decades ago, although we didn't have the reasoning behind it, we talk about the January thaw, which seemed to come around the 3rd week, roughly in January. But that clearly implies it's pretty consistently cold before and pretty consistently cold afterwards. That would be a joke now, because we've had so many thaws before we ever get to that. And so there were only, I think, 4 or 6 at the most days this winter season where it stayed below 32 in Boston for the entire 24-hour period. The average is 21. Again, this is one specific winter, and some of the patterns were contributing. A La Nina does usually favor warmth along the East Coast. So that played out, as well as a lot of action farther to the west. But there seems to be no question that, and some of the talk about weather patterns has been, we've seen the greatest amount of warming in the high latitudes, which has been anticipated. And so the polar vortex, which is, you know, on average up there in the polar regions, but because of the warming up there, it's at times getting elongated and stretched. And that's how you can kind of get an occasional real cold outbreak in but it usually doesn't last that long. It also can affect the jet stream and allow storms to take a track that could be favorable for significant snow. So when we look at 1980 to 2010, and then we look at the climatological record going 10 years later, 1990 to 2020, Boston's climate is clearly warmed. However, the average snowfall has actually gone up. And that's because of that shift of the jet stream. It's almost like if you imagine the jet stream moving from west to east, this warming in the high latitudes is causing more undulations, and you get more ridges and troughs, and you can get more storms. You don't have it quite as cold. Now, even if that were to continue, somewhere down the road, some of those snowstorms will likely become rainstorms. So for now, it's increased the average snowfall, but that probably won't be sustained. But the warming probably will, unless, we as a world do more things to try to mitigate that.
Yeah, thank you, Harvey.
Sure.
Mark, do you have anything you'd like to add?
No, I think Harvey covered it really well.
Great. I have a question for you, Mark. I think this is Mark Borrelli territory. How do relative sea level changes correlate with global sea levels? And are these some, main factors that play a big role, or are there main factors that play a big role in their relationship?
Sure. Well, yeah. So how are they related? So global sea level rise is sort of the background, right? That's what everybody experiences, and it's identical. So obviously they're both sea level, so they're related, but global sea level rise is just the same everywhere. That's why it's called global sea level rise. Relative sea level rise is much more complex because there's so many different factors, right? Here, unfortunately, in the Northeast, we're going to have a relatively high, we're going to have one of the highest rates of relative sea level rise in the Northeast. On the East Coast, sorry. So it's going to be pretty high, in part because of the Gulf Stream we think is going to slow down, and the sea levels are going to rise up a little bit. In part because of the warming of the water. The Gulf of Maine, for those of you who don't know, is warming faster than I think about 99% of the large bodies of water in the world, right? So that's going to have an effect. So in terms of relative sea level rise, there's not really a correlation per se. But the relative sea level rise in one area does have a major impact in those areas.
Thank you.
Sure.
This next question is about, communicating the risks of sea level rise and coastal storms to the general public. Do you have any helpful recommendations on how to best communicate the risks of sea level rise and coastal storms? And do you have any additional advice on ways to help residents get engaged in climate resiliency efforts?
The thing I would say about storms and sea level rise, and I should have said this during the talk, but you will see the impacts of sea level rise most clearly during a storm, right? That's as sea level rise slowly comes up. These storms, the storm of 2018, January 2018, was slightly higher than the blizzard of 78 in terms of total water level. It wasn't that much. It was just a little bit, almost like an inch, less than an inch higher in Boston. But if you look at the rate of sea level rise between 1978 and 2018, those 40 years, it was much higher than that inch. So because of sea level rise between 1978 and 2018, we have a new storm of record, right? Because the rate of sea level rise happened. If there was no sea level rise, the blizzard of 78 would still be, as far as total water level goes, our storm of record. So you're going to see that impact. And it's always going to happen during storms because that's when people pay attention, right? Although the sunny day flooding, this nuisance flooding, high tide flooding, that's a precursor, right? That's your preview of what's going to happen as these things become more and more frequent.
I just want to add one thing to that.
Yeah.
It is interesting that the 2018 storm, had a slightly higher water level than the blizzard of 78, and yet the blizzard of 78, the storm was interacting with a very large high pressure area, creating quite a gradient. And actually, with the 2018 storm, there was virtually no high pressure area. The storm had to kind of create it by itself. But this plays exactly into what Mark just said. It allowed a situation that wasn't even on the weather map quite as dramatic as 1978, and yet the effect along the coast in terms of the water level was actually a little bit higher. So that explains, that's exactly what Mark's talking about.
It was kind of a nice day. If people remember January 4th, 2018, it wasn't bad. I mean, it wasn't super windy. It wasn't too bad. It was kind of a nice day.
Yeah. I think that was the only real good storm that winter season, but I could be wrong, but I think it was the only one. That's how I remember winters, but I'm weird, so you can't go.
So this next question is kind of related to water levels and, storms hitting at certain tide level. The question is, what would have happened if Sandy had hit at high tide? And if I'm remembering correctly, Sandy did hit when the tide was very high. So maybe you could just kind of speak to, how that changes storm impacts when, we see a major storm hit at high tide.
Well, it's huge. I'm going to let Mark, cover this, but since I can go far back, I will tell you this. I was around for Hurricane Gloria. That's 1985. Okay. And that storm at one time was like a Category 5, well off the Carolina coast. Then it was a Category 3 abreast of Cape Hatteras. Fortunately, it only moved at 15 to 20 miles per hour, not 40 to 60. So it weakened a little bit more. It came onto Long Island as a Category 2, came onto the southern coast of New England as a Category 1. But it still took the classic track that would have caused a lot of coastal flooding along the south coast and the Cape, but it hit at low tide. So there was no real coastal flooding whatsoever. There were a lot of downed trees, and you heard the chainsaws the next day. But in the media, the talk was, oh, the storm didn't live up to what it was supposed to. And part of that was because the peak of it coincided with low tide as opposed to high tide. With Hurricane Bob in 1991, down across extreme southeastern Mass and the Cape, there was considerably more coastal flooding. And I remember driving along Falmouth Heights. And again, the seawall was in blocks of concrete. But that did coincide with high tide. So, it was a little bit stronger than Gloria, but not that much. But the difference between low tide and high tide made an immense difference.
Yeah, and we're so used to nor'easters up here where storm surges are 3 feet and 4 feet and 5 feet are massive, right? Don't forget what happens during hurricanes. And storm surges can be much, much bigger, right? They can be 2, 3, 4 times that. So if climates continue to warm and things like Sandy keep moving further up the coast, we could start experiencing things that we've never really experienced before. So that sort of will supersede the tides. If storm surge gets so high that they're actually, closing that window of when we're going to see those really, really high water levels, that's kind of a game changer.
Yeah, thank you both. This next question, I think addresses the fact that there are a lot of different opinions about how to address climate change, whether to address it. How would you respond to people who might say that addressing climate change can hurt the economy? Vested business interests, people maybe wanting those things to stay the same.
Well,
Harvey?
Well, first of all, I think that we're talking about Boston Harbor in our local area, but first of all, you're probably going to get a lot of different responses in different parts of the country because, in order to try to combat climate change, if we really try hard to get away from fossil fuels quickly, what happens to the economy? So if you're in West Virginia and a lot of people are coal miners and, they get scared they're going to lose their jobs. It's a challenge. And then there are also some people who are saying, look, we could do the best we can do all the right things here in the United States. But what happens if much of the rest of the world or China and India don't do anything? So, you really need a worldwide effort, ideally. But, there's only so much we can control and so much we can't. But, I think some of this is, I don't know about solvable, but at least mitigation is really important. And I'm not a structural engineer or an architect, but I do know there's been a lot of construction in the seaport area, and that's obviously a very vulnerable area. And I do know that what can you do? Well, I presume you can have higher foundations. I think I know that in some cases, if they're using furnaces, they don't put them in the basement or the bottom floor. They're putting higher up so that if you do encounter flooding, you're trying to mitigate. The great if you can, whatever we can do to not make this happen. But the other thing is mitigating and adapting. And new structures, one thing, but to change existing structures is more complicated. I guess that's called retrofitting. But again, I'm not an engineer. I'm certainly not a structural engineer. But it's challenging. But
and I'm not an economist, but if we look at sort of the mid to high range of sea level rise by 2100, we're talking about 5, 6, 7 feet. 7 feet of sea level rise in coastal areas around the world. If you want to talk about an economic impact, the economic impact of 7 feet of water along the coastal environments of the United States alone is unimaginable. It is literally unimaginable. It is going to be way more cost effective. And again, I'm not an economist, to do something to stop that or prepare for it than to just let it happen. Because I can't imagine what the economy would be like if all of our port cities were 6 or 7 feet underwater. It's unimaginable.
Yep.
Yeah.
I think I read somewhere not too long ago, whatever I'm saying is close either way, something like 50% of the population in our country lives within 55 miles of the shoreline, or it's 55 and 50, one or the other, but you get the idea. So there are an awful lot of people near and along the shoreline.
Yeah. Yeah, and with that, we've gotten a lot of great questions in the Q&A area, and we have not gotten to answer them all, but I do just one last question to end with that maybe both of you could quickly reflect on before we wrap up. With such dramatic climate change data, I think a lot of people often wonder, how do we stay hopeful amidst that?
Okay, well, that's a good question, challenging. I just look at it this way, and I know we're not here to talk, politics, and we know there's, that rubber band is stretched a lot in this country, and it's pretty scary to a lot of us, that people are lined up, here instead of closer to there. But I still think that hopefully reason and sensibility and at least some compromise will occur. I know a lot of people saying, well, if we try to get off of fossil fuels so quickly, it'll be an economic disaster. But, we at least, I think, have to continue moving in that direction. And I'm hopeful that maybe reason will, prevail. We have to at least, be going in the right direction and more aggressively. But, maybe there is a question. You do have to balance to some extent the economic aspect of it. If you try to create too dramatic a change too fast, it might not be achievable. You might not gain what you want. You may hurt some people, whatever. But hopefully, at least I want to think optimistically that we know the change has to come. It's in the process already. Hopefully it will be more over time, and hopefully a fair part of the world will follow if we take the right lead.
Yeah, that was well said. I'm hopeful because we're here talking about it. Right, we've all spent 40, 50, 60 people have spent an hour and a half listening and talking and asking questions, and that's what makes me hopeful that we're all thinking about it. Yeah,
absolutely. And with that, thank you both, Mark and Harvey, for being here. 2 great presentations. And before I pass it over to Mark Albert to close us out, just thank you to the audience, all of your great questions. It's been a pleasure to be here with everyone tonight.
Thank you. It was a pleasure indeed.
Thank you.
Yeah, that was great. And I'll just say that, in partial answer to the last question, that we as a sort of society, a global society, have made some dramatic quick transformations in the past. And perhaps this is the next factor that will force us to make a dramatic shift in how humans live on the earth. Yeah, that was great. Thank you so much, Harvey and Mark, and thank you, Kathy, for moderating. The National Park Service and Boston Harbor Now thank all of you in the audience for joining us and for great questions. This program is the second of our Revolutionary Harbor lecture series this year. The final program will be on April 13th, titled We're Still Here, a conversation with Ferris Gray, Sagamore of the Massachusetts tribe at Ponkapog. It should really be fantastic as well. For additional information on that and other upcoming events, please keep an eye on the calendar at bostonharborislands.org, all one word. And thanks for putting that in the chat. Thank you again, everyone, and have a wonderful night.